Hello everybody. In this video I am going to show you how to add or subtract vectors, especially for force vectors, using force triangles. Okay? But before that, let's talk a little bit about the force vectors. What is basically a force vector? This is a vector because this one force has its magnitude and its direction. Now what is force? Force is basically any action that will try to move a mass or tend to move the mass. Like sometimes the mass may not move, or sometimes it can move with a constant acceleration, right? You learned that one in your physics class. Now, in this class, like statics is about the subject which doesn't move. Means like when you are applying a load, then basically there is a reaction for that load and the mass is not moving. If it moves, then basically this is beyond the scope of statics and maybe the part of dynamics. Okay, so in this course everything is static. Okay, now if I show you the vector for any vector, you can see, let's say this is a vector here. You can see we say this one is head, this is the tail. The line along which this vector is working, we call that one line of action. And this is the direction. Now, sometimes we call that one the sense of the vector. Okay, so we usually vector has a magnitude. Let's say this is 100 pounds, and the direction is, let's say this one is making 40 degrees with the horizon. Okay, we usually denote the vector with that. Let's say this is F. That's the vector. When you talk about the magnitude of that vector, that's actually only F 100, and definitely this is the direction. Okay, now you can see that when the vectors are working in the same line, then basically we can add vectors like scalars, right? Let's say one force is working here, the other force is working the same direction. This is like 10 pounds and this is 10 pounds. So we can say that the resultant of these two forces is actually 20 pounds. But when they are not at the same line of action, then basically we have to go for a different methods. In your physics class you already learned how to add two vectors using parallelogram, right? Parallelogram, like in this course actually we are not going to use the parallelogram. We are going to use three different other methods. Let me write it down. Force triangle method. Then number two, we'll use for couplet, like two-dimensional cases. Let's say for coplanar forces, we are just going to use a method which is called rectangular axis method, and then the final is definitely the using the vector notations. So we are going to use the vector notations only for 3D cases, okay? And for this one, like for coplanar forces, we are just going to use the rectangular axis method. This one is actually very, very helpful when we have more than two forces, because that time the force triangle doesn't work that good because it takes much longer time to solve the problems, okay? We'll talk about that later on. Now let's try to focus on force triangle, okay? Let's say I have one force here, which is A, and I have another force here, which is B. And I want to find out the resultant of these two force vectors, okay? So what I have to do, actually, I have to go to the head of the first vector and then draw a parallel line with the force vector B, and basically this is the resultant of A plus B, okay? Very similar to your parallelogram method, because in parallelogram you can see that this one looks like so rather than using the whole parallelogram, here we are just using one of that triangle from there. Similar triangle here, we are just going to use one of that triangle. What is the advantage of that method? The advantage of that method is parallelogram method. If you go to like triangular force triangle method, then basically you can use the universal rule of that triangle, and then basically you can find out the angles and this length quite easily, okay? Now what are those triangle rule for triangle? We have like cosine rule and sine rule. So for sine rule, let's say this is my triangle, and this angle, opposite of this angle is A, the opposite of this angle is B, lowercase b, and then let's say this one is lowercase r, okay? And this is the magnitude of A, B, and R, okay? So the sine rule is saying that A by sine A is equal to B by sine B is equal to R by sine R. Okay? So these A, B, and R, these are the length here of the triangle, and this is the angle opposite to A, this is the angle B opposite to B, and this is the angle opposite to R. Okay, this is the sine rule. We also have cosine rule. What is that cosine rule? So here you can see that cosine rule is basically r square, or R is equal to a square plus b square minus 2ab cosine R. R is the angle between A and B. Okay? Similarly, we can say that A is equal to cosine and the angle between B and R. Okay, so B and R, the angle is A. R, we can say B is equal to cosine B. A and R, this angle is in between A and R. So A and R is actually the angle is B. So you can use these three equations of these three equations here, but I'll recommend you to see, like when you draw the fourth triangle, then try to see that whether you know any two arm and the angle between them. If this is given, then basically use the cosine rule. If it's not given, then basically you use the sine rule to solve your problem. Okay? So now let's see some of the examples here. I'll just show some of the problems from your book. The first one is basically problem number 212. That's from your book actually, okay? So this is 2-12. This one is saying that determine the angle of theta for connecting members A to the plate so that the resultant force Fa and Fb is directed horizontally to the right. Also, what is the magnitude of the resultant force? Let me draw that one here first. So one of that force is working in that direction. The angle here is 40 degrees. There is another force here which is actually 8 kilonewton. This is 6 kilonewton. This angle is theta, and it's saying that the resultant of these two forces is working here along the x-axis, okay? Like this. Now we have to first construct the force triangle. To do that, I have to do, like, let's say I can either go to the head of this force or this force. Let's say like this force here, and I draw the parallel line here. Okay, which is actually 6 kilonewton. right? So you can see that's basically your resultant here. Now you can also see, since this angle is 50 degrees here, so this one and this one is parallel and this one is connecting to this one, so this angle has to be 50. That's actually coming from your geometry, okay? Geometry and trigonometry, like you have to use both of them. And you can see this one is actually, total is 90 minus theta, right? So you can see here, actually this one is given and this one is given, but the angle between them is not known. So that's why we cannot use the cosine rule here. So we have to use the sine rule, okay? So if I use the sine rule, so I know this one and I know this one, so I'll say 6 divided by sine the opposite angle, which is 90 minus theta, is equal to 8 divided by sine 50. Okay, so sine 90 minus theta is basically 6 sine 50 degree divided by 8. So if you plug the value of sine 30 and solve that one, then basically you get your theta is equal to actually 90 minus theta is equal to sine inverse 6 sine 50 divided by 8. So that's so your theta is basically equal to 54.90. Okay, so if this theta is 54.9 degrees, then this one is 90 minus theta, which is basically 35. This angle is actually 35.9 degree. Okay, so what would be this angle then? That would be this angle, let's say this is alpha. So alpha would be equal to 180 minus 50 minus 35.9, which is actually 94.93 degree. Okay, so now you know the angle between these two, so you can use the cosine rule. So your R would be equal to 8 square plus 6 square minus 2 into 8 into 6 cosine 94.93 degrees. That's basically 10.4 kilonewton. So that's the answer. Okay. Now let's try to do one more problem in which actually we have to dissolve the force into two components. Okay, this force triangle method is very, very essential if you want to dissolve any force into a axis which is not 90 degree. Okay, which is not 90 degree. If the axis is not 90 degree, then basically this is the only method you can use to dissolve the force into two components. Okay, now let's try one more problem here, how you can dissolve that force. This is like problem number 220. So this one is showing, let me draw that figure here. This is basically 400 pounds. Now this one is saying that determine the design angle phi, which is in between 0 and 90, which can vary from 0 to 90 degrees, between struts AB and AC, so that the 400 pound horizontal force has a component of 600 pounds which acts up to the left in the same direction from B towards A. So if I want to draw the force triangle, then basically what I have to do, that this one is saying that, let me draw that one. And one of that component is working from B to A, this is my A, in this direction, which is 600. So one of the component is working here, and if you draw the other one along this line, because this force will be taken by these two frame, so you can draw a line which is actually parallel to this line here. Now this one is 600 here. You can see this angle has to be this angle here, which is actually theta. So this is 30 degree here. You can also see that that's actually your angle phi here. Now you can see this one and this one is parallel, and this one is intersecting the two parallel lines. So if this one has to be equal to this one, right? So if I draw this whole thing a little bigger here, just for clarity, then you can see here, this one looks like this. So this one is 400 here. This is 600 here. We are trying to find out this component along that line, which is, let's say, I don't know that one here, and this angle is your phi. So basically they are trying to find out the angle phi, which can vary from 0 to 90 degree, okay? So you can see, actually I know the length of this triangle also, like this arm here and the angle between them, so easily I can find out my R using the cosine rule, right? So use the cosine rule. You can see your R is basically 400 plus square plus 600 square minus 2 into 400 into 600 cosine 30 degree, which is basically 322.97. That many pounds. So this one is basically 322.97. So if I know this one now, then basically I can easily use the sine rule here, that (400) divided by sine phi is equal to 322 divided by sine 30. I'm not using 600 by this because I don't know this angle. That's why I'm not using that one, okay? So if you plug all those values, then basically your sine phi is 400 into sine 30 divided by 322.97. So your phi is basically 38.3 degree. So that's basically your answer. Okay? So one of the important things is, like, when you take the phi equal to sine inverse of this one, then basically you can get two angles there. One is this, and the other one would be 180 minus 38.3, but since this one is higher than 90, so we are not going to consider that one, okay? So that's basically the answer here. Now let's move forward to the third problem, which is a little bit different type. In your book, the problem looks like problem number 2-28. So this one is saying Now they are asking determine the magnitude of the force F so that the resultant Fr of the three forces is as small as possible. What is the minimum magnitude of Fr? This one is a little bit difficult one. But if you see this one, you can see that we don't have that many problems in this chapter. But for your understanding, I'm just trying to do that one so that if you see this kinds of problem, then basically you can solve it easily. Okay? So first of all, what I'll do, what they're asking actually. They're asking like what's the value of F so that the resultant of all that three forces would be minimum. Okay? So to do that, first of all, I'll try to find out the resultant of these two forces first because I already know the resultant of these two forces. Okay? So this is your basically resultant. So since this one is 90 degree here, so you can see this one is basically right? You can use, this is from the Pythagoras formula, but if you use the cosine rule, then basically you will see that 8 square plus 6 square minus 2 into 8 into 6 cosine 90. But cosine 90 equal to 0, so basically you will get your r equal to this square plus this square. Okay? The same way you can just do that. Now you can also find out this angle here. Okay? So the angle here, let's say this is theta of the resultant angle that's making with the vertical, or you can just say like, hey, what angle this one is making with the horizontal doesn't matter. So let's say this is alpha. So tan alpha is basically 8 by 6. So alpha is equal to tan inverse which is basically 53.13 degree. Okay? So rather than showing these two forces here, let's say this is my x-axis and this is my y-axis here. I can show, rather than these two forces, I can show only the resultant which is working along here. And this one, this angle is 53.13. Okay? To find out now the resultant of this force and this force, this is actually the resultant of these two, and if you add F with that, then basically you will get the resultant of the three, like forces there, right? So to draw the force triangle for that one, you can see what I have to do. I have to go to here and then I have to draw a parallel line here. Since this value of f is not given. So it could be here, it could be here, it could be here, right? I don't know. But they gave you a clue that the resultant would be minimum. So the resultant would be something like this, right? So this is your let's say for this one, this is your R1, this is R2 and R3, and I'm trying to see that which one would be minimum. So if you see like R1, R2 and R3, these are the distance from here to this line. So which one would be the minimum? The minimum one would be the perpendicular distance from there, right? So we can say like, well, for minimum resultant, this one should be here, so that this angle is 90 degrees. Okay? So this one is your F, this one is 10, the angle of this one will be how much? You can see this one and this one is parallel, this one is connecting that one, so this angle has to be equal to this angle, right? So this angle is actually 53.13 plus 30 degree, that's actually 83.13 degrees. Okay? So you can see again that I draw that line such a way that R1 is minimum, and that minimum would be only possible when this one is the perpendicular distance from that point to that line, right? So in that situation we can just find out F1 from here. So what would be this angle here? If this is 90 and this is 83.19, so this one has to be 90 minus 83.13, which is basically 6.87 degrees, right? So if you use your sine rule now, then you can just say, let me do that one here. You can say 10 divided sine 90 is equal to F divided by sine 6.87, sorry. So sine 90 is basically 1, so F is equal to 10 sine 6.87, which is 1.2 kilonewton. Similarly, you can find out also the resultant of this one, like use, let's say, 10 divided by sine 90 is equal to R divided by sine 83.13 So R is basically 10 sine 83.13, which is 9.93 kilonewton. Okay, so basically when they are saying that find out your F for the resultant would be minimum, that's actually giving you a clue that the line of the resultant has to be perpendicular on F. Okay, that's the example for this particular method, and in our next video I'll show you how to do that, dissolve the force vectors into rectangle components and how to use that method. Okay, bye.